Okay, let's move on. And our next topic is industry-scale energy storage for process steam decarbonisation. Please welcome Emil Løvschall-Jensen, CEO and co-founder at Hyme Energy, on stage. The stage is yours.
So thanks for the opportunity to be here. I'm going to give you a window peek into a startup's journey bringing large-scale energy storage to the market. I want to start by some of the things that motivates me the most. We live in a world that's still driven by fossil fuels. That's a reality. 80% of all the energy that is produced comes from fossil fuels today. And the 20% that is as electricity is only a smaller share of that that's actually from sustainable and renewable sources. So for a green transition, we need to increase the amount of power drastically in the grids to electrify the other sectors. We need to shift from the time where it's produced to where it's needed. But we also need to replace the fossil fuels that are an integral part of the transportation sector in power-to-X projects, but also in the heat sector. Half of all the energy we use is in heating. 1/3 is in process industry, and half of that is at temperatures above 200 degrees. So above the temperatures where heat pumps can go, where there's an actual technology gap today. And that's where thermal energy storage is going to play a vital role. Hyme is a company developing large-scale utility and industry-scale thermal energy storage to replace natural gas directly in the industry and to replace coal boilers and biomass boilers in power plants. And at the core is a use of a novel salt, or more correctly speaking, salt that has existed for a very long time, but is being produced in close to 100 million tons around the globe every year. It's the group called hydroxide salts. You might know sodium hydroxide, caustic soda. It's inexpensive. It's produced from salt water, which is interesting as a storage medium because it means that this is the one thing that we can scale infinitely. But it's also extremely compact when it comes to energy density and footprint. It's inexpensive, it's non-toxic and unflammable. It's also highly corrosive, but that's what is at the core of Hyme's technology. It's developing and industrializing the chemistry control system that allows us to use this in storage plants. So for a storage plant, we deploy on-grid. Power comes in, it's used to provide heat, to heat up the molten salts. In the hot tank, we can have up to several gigawatt hours in one tank filled with hot salt that is discharged through steam generation, either for direct process steam applications or for cogeneration. The interesting aspect is the footprint. It is extremely compact, which means that it fits on-site at industry sites next to the natural gas boiler that today provides that steam. But it's also a system that can charge and discharge independently. So we can fill it up in 6 to 8 hours, charging when there's wind available at night and tariffs are low, or when there's a solar peak during the day. But having cases that discharge from 8 hours a day, but all the way up to 24 hours a day. And this is critical because a lot of the industry clients that we're talking to, they have their feedstock production 24/7, up to 11 months a year. So it's a constant discharge, it's a constant burning of natural gas today to provide the steam at 200 or 300 degrees for the process. We took a large step in August when we kicked off the construction of the first industry-scale pilot in Denmark. This was a conceptual drawing of it, or animation of it. I want to show you how the industry side actually looks, because it's been fantastic to see the progress over time as a startup, as all your components come together, all the suppliers we work with and the EPC partners, we actually managed to get these 2,000 components into a working pilot that is industry scale. And these are just close-ups of the finished construction of both the heat exchangers and part of the tank systems there. The pilot is going to be inaugurated on the 21st of April. So that's going to be a world's first. I'm proud of that. But I think what's perhaps even more important about that story is not just that we are providing this design and technology development to make this a reality, but also the supply chain and partners around it. Because getting new technologies to market is not that simple. Because if it was easy, then it would have been done several decades ago. The technologies that we need to actually shift the infrastructure is novel technologies that can provide an actual difference and that are bought into a world where flexibility is a demand, where constant discharge is a demand, and where renewable integration is a demand. We have the first operational integration project already. It's going to be on Bornholm, this island in east of Denmark in the Baltic Sea. It's inside an operating biomass plant and will provide steam directly into that operating asset. But the primary pull is from industry clients, where we will directly replace natural gas with a value proposition that we can give 100% electrification, but you can also imagine a hybrid scenario where you retain your natural gas boiler and use that to burn perhaps biogas for the 1 to 2 months a year where there's too little share of renewables in the grid. But for the remaining 7,000 hours a year, you run entirely on grid-connected energy storage plant that can be sourcing green electricity. So it is a proposition to not take an incremental decarbonization, but a full step to fully replace and allow you to produce your milk powder or your sunflower oil or your cardboard or your chemical feedstock using 100% green power. What is interesting to see is that we work with customers directly on their expectation to power prices in the future, their expectations to the ancillary market and to natural gas prices. And we can showcase, at least in the right markets in Europe, in the right countries, we already now show cost competitive models with natural gas directly. We see the retrofit of coal power plants as a follow-up market. There's a very large fleet of power plants in Europe that are going to be decommissioned in the next 10 years. Poland is one of the best examples, but there's other places. It's sites where there is existing grid connections, there's existing heat customers, there's an existing steam turbine generator. And due to the salt that we utilize, we can actually provide the steam at the temperature and pressure, so it can feed directly into an existing steam turbine. So in terms of momentum in a transition, it's one of the cases that we see as the most important, perhaps, for Europe at a very large scale. But we also only see it coming online in 2030 and onwards, because that's the lifetime that these coal power plants or biomass plants still have left in them, and where the decision to go to natural gas or other technologies would come into play. And I think I want to stop the presentation there. You're more than welcome to reach out, both as investors, but also as industry partners or other players in the field. We're working actively both to deliver turnkey projects to customers that would like to own and operate themselves, but we're also working very actively with infrastructure partners that would like to have the customers actually being heat off-takers on a heat as a service agreement, and where we do the funds across sectors and across customers for project financing. And it's one of the best ways to actually both de-risk it, but also have the assets management and the energy trading benefits that these assets come with into play. So thank you for your time.